Alright, lesson 8.4 is about similarity in right triangles. And our objective is to find and use relationships in similar right triangles. So our new theorem is theorem 8.3, which says that if the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and similar to each other. So if I can't draw a perfect right triangle, but we're going to pretend. What this is saying is if I draw from the height of the triangle to the hypotenuse, then these two right triangles are similar to the original right triangle and to each other. Okay, the corollary 1 to theorem 8.3 is that the length of the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So if I know what this segment is and what this segment is of the hypotenuse, then I know that the value of the altitude is the geometric mean of those two pieces. Corollary 2 to theorem 8.3 is the altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent hypotenuse segment. And the length of the hypotenuse. Okay, then we need to know how to find the geometric mean. So the geometric mean of two positive numbers a and b is the positive number x such that a over x equals x over b. So if you solve this, x equals the square root of ab. And that is going to be important. Okay, so let's put these theorems and corollaries to use in the examples. So first, example 1 says to find the geometric mean of 3 and 12. So first we're just going to practice finding a geometric mean. So 3 over x equals x over 12. We write their proportion just like we have over here in the definition. And then if we use the cross product property, x times x is x squared. 3 times 12 is 36. So if we take the square root of both sides to find x, the square root of 36 is 6. So the geometric mean of 3 and 12 is 6. Okay, so that one's just a proportion, which we already know how to solve. Okay, then number 2, finding distance. So at a golf course, Maria drove her ball 192 yards straight toward the cup. Her brother Gabriel drove his ball 240 yards, but not toward the cup. The diagram shows the result. Find x and y, their remaining distances to the cup. Use corollary 2 of theorem 8.3 to solve for x. So, we're going to use corollary 2 from here. So, x plus 192, so we get this whole hypotenuse segment over 240. Okay, so we're using hypotenuse over adjacent side. And then in the other triangle, we're using 240, which is the hypotenuse of this side, and the adjacent side would be 192. Okay, so we're using the hypotenuse and the longer leg of each of these two triangles. Okay, so if we cross multiply, so we're using the cross product property, we would have 240 times 240, and then 192 times x plus 192. So then if we use the distributive property, we've got 192x plus 36,864 equals 240 squared, which was 57,600. So then if we subtract 36,864 to the other side, 192x equals 20,736. So then if we divide both sides by 192, x equals 108. Okay, so we found x. Now we're going to use the same corollary to solve for y. So I'm going to erase these marks so we can look at what we're using this time. Okay, so x plus 192, we're using this hypotenuse again. This time we're going to use the shorter leg, y. So x plus 192 over y. And then we're going to set that equal to y, which is the hypotenuse, over the shorter leg, x. Okay, so that's all set up for us. So we actually know that x is 108, so we're going to replace x with 108. And again, it's over y. So all we did here was substitute 108 for x. So then we need to simplify so that, like, we can add 108 plus 192 and we get 300. It's still over y, and this one is still over 108. Okay, so then we can use our cross product property. To multiply, so we'd have y times y, which is y squared, and 300 times 108, which is 32,400. Okay, then we have to take the square root of 32,400 to figure out what y is. And the square root of 32,400 is 180. So we know Maria's ball is 108 yards from the cup, because this was where Maria ended, so x was her distance to the cup. And Gabriel's ball is 180 yards from the cup, because point G is Gabriel's ball. Okay, you only have 2 check for understanding problems. Recall example 2, find the distance between Maria's ball and Gabriel's ball. So you're going to try to find this distance here. And there's a couple different ways you could do that. Use what you think is the easiest for you. You can use one of the corollaries in this. You could decide to use the Pythagorean theorem, either way. Okay, then number 2 says find the geometric mean of 15 and 20, and this is going to be just like in example 1, where we found the geometric mean of 3 and 12. So go ahead, try those out. You should have everything you need to go ahead and do that. If you have any questions, make sure you're asking. I'm here to help you out.